All right, let's take a look at one more form of factoring here in the 4.2 section. So again, we're going to be talking about binomials and quadratic trinomials. So let's do a quick definition again here. Here's the responses over here. So a binomial is a polynomial with exactly two terms. And a quadratic trinomial. Quadratic stands for an x squared, and a trinomial means three terms. So we're going to put a second degree polynomial. That's when there's an x squared that has three terms. Here is the general form of a quadratic trinomial. And then we're going to go use the equation editor to type in ax squared plus bx plus c. And so a, b, and c stand for coefficients in front of the variables. Okay. So we've got a polynomial with exactly two terms and a second degree polynomial, or an x squared, that has three terms, is our quadratic trinomial. Okay, so now we're going to go through the practice with a little chart here. All right, so we're saying, here's the rule in words. I've got this x squared plus bx plus c. That's my standard form of a quadratic trinomial. And this is going to give us two factors, p and q, that where the product of these form the constant term at the end, c, and where the sum or difference of these form the coefficient of the middle, b. So let's go test this out. P times q. What number times what number equals c? And then we want, for example, in this one, that what are the p and what are the q? They are 2 and 5. So 2 times 5 are what form the 10 at the end. So this end number here and this end number here form the constant. So in this case with numbers, 2 times 5 equals the 10. Now we want a number where we sum them and get the middle coefficient. So p plus q is going to equal that b coefficient, or 2 plus 5 equals 7. So what plus what equals 7? 2 and 5. What times what equals 10? 2 times 5 equals 10. So my two factors are x plus 2 and x plus 5. Next, we're going to write plus or minus for each of the factors to see what would actually effectively give me this correct trinomial. So for example, 3 times 3 equals 9. We're trying to decide on the signs. So here, this would need to be a plus. I can't make that one bold. So let's go back to this one's going to need to be a plus. And then this one is also going to need to be a plus, because positive 3 times positive 3 equals positive 9, and positive 3 plus 3 equals 6. B and C are both negative, then P and Q have opposite signs. So when these are both negative, these are going to need opposite signs. So since I need one positive and one negative, the larger factor is always going to have the same sign as the middle. The larger factor will always have the same sign as the middle. So that at least gives you a hint to here the 6 is the larger factor, so that's definitely going to be the minus. So x minus 6, and then that makes this other one have to be the positive. So let's test it out. Positive 2 times negative 6 does make negative 12. Negative 6 plus 2 does equal negative 4. If B is positive and C is negative, then they also have to have opposite signs. But this time I want the larger factor to always have the same sign as the middle. So since 4 is positive, I want the larger factor to have a positive. And that means the other one needs to be negative. Because we need one of each. Finally, if the end is positive but the middle is negative, this is where both have to be negative, because a negative times a negative equals a positive. Okay, how do these follow these steps in order to factor x squared plus 13x plus 12? So identify the c in the trinomial. So the c is plus 12, or positive 12. So now p times q and p plus q is what we're interested in. So find all the possible factor pairs for c, and then list each pair as a p and q in one row. So for example, 1 and 12 make 12. 2 and 6 make 12. 3 and 4 make 12. So those are all my factor pairs. Find the sum of each factor pair in the correct row of the table. So 1 plus 12, that makes 13. 2 plus 6, that makes 8. And 3 plus 4, that makes 7. Find the sum of each factor pair is done in the table. Now identify b in the trinomial, which happens to be 13. Go back to the factor pair that had the same sum as your b. So that's when p was 1 and q was 12. Write p and q in the form of x plus p and x plus q, and that's your final answer here. So we're going to write parentheses, x plus 1 and x plus 12. And those are my two factors, known as the p and the q. So we want to identify here the c and the b. So we're looking for a negative 15. What times what equals negative 15? And what times what equals 2? So what times what equals negative 15 and adds or subtracts to 2? And so again, here come all the factor pair possibilities for 15. 1 times negative 15, 3 times negative 5, 1 times positive 15, and 3 times negative 5. Sorry, positive 5. Now we're going to subtract or add these up. 1 minus 15 equals negative 14. 3 minus 5 equals negative 2. Negative 1 plus 15 is positive 14. And negative 3 plus 5 equals 2. which of these equals the b that I want? Here it is right here. Here it is right here. So my factor pairs are -3 and +5. And so therefore, my factors are x minus 3 and x plus 5. All right, what times what equals 20? And adds or subtracts to -9. So what P and what Q to get me 20? So this would be a -1 times -20. That's my first possible pair of factors. Then we say what else times what else makes 20? How about 5 and 4? That's going to be down here, -5 times -4. And that gives me +20, so that's looking good. But there's also the possibility of -2 and -10, and -2 and -10 add up to -12. So again, I'm looking for all of these multiply. These are my possible pairs for +20, but which one gives me the b that I want when I subtract or add them? And that gives me the -9 right there. So here I go, my p is -4, my q is -5, and so my two factors are x minus 4 and x minus 5. How'd you do? Now there's just a blank page here that I'm just going to show you a couple tricks on. Before you go on to the checkup practice problems, you're going to know I use a different method here. So I'm just going to show you just a trick that I use students. It's just a tool that if this way seems easier to you, you are welcome to use this way. It's how I do the checkup problems as well. So let's say we have x squared minus 2x minus 8, okay? Again, we're supposed to think what times what equals this and adds or subtracts to this. We do this thing called the diamond, the magic X. Different teachers call it different things. Here's what I do. This corner is touching the front here and touching the front here. Invisible 1 times -8, or also known as the A times C, goes in the top of this little tool here. So this is what times what equals -8, and then this coefficient drops down, -2 goes here. So what times what equals 8, and subtracts to give me -2. So my factors are x minus 4 and x plus 2. Let's do another example. X squared minus 3x minus 40. What times what equals -40 and subtracts to give me 3? So what times what is 40? Now we're deciding on signs. Sign of the larger factor is always going to match the bottom. So -8 plus 5 are my factors. I write it out as x minus 8, x plus 5. Let's go try one more. What times what equals 3 and adds up to 4? 1 times 3 adds up to 4. My two factors are x plus 1, x plus 3. What times what makes negative 7 and adds or subtracts to negative 6. 7 is just 7 times 1. Which signs do they need to have to get me a negative 6? X minus 7, x plus 1. This is the tool I'm going to be showing you guys in class tomorrow on a quick way to do these problems.